All right, ready to dive into something pretty cool today.
Yeah, definitely.
Today, we're looking at some really interesting research out of École Polytechnique Fédérale de Lausanne, or EPFL for short.
Oh, cool.
They're exploring, this is cutting-edge stuff, combining robotics with spinal stimulation.
Wow.
The idea is to use this combo to help restore movement in people who've experienced spinal cord injuries.
I mean, spinal cord injuries are just devastating.
Absolutely. You know, the impact on mobility is just huge. So we've got some great information on this new approach.
Awesome.
So robotics and rehabilitation, it's not exactly new, is it?
Right.
But the thing is, traditional rehab robots, they kind of just move the limbs for the patient.
Yeah.
They're not really engaging the person's own muscles in the process.
And that's a problem because...
Yeah, it limits how much the nervous system can actually relearn.
Exactly. It's
Yeah.
like the robot's doing all the work instead of guiding the person to do it themselves.
Right.
And that's where this new approach comes in.
Yeah, so what are they doing differently?
So there's this team at EPFL. NeuroRestore, they've been working with Professor Ice Beert's robotics lab, also at EPFL.
Okay.
And together they've developed a system that basically integrates an implanted spinal cord neuroprosthesis with these rehab robots.
So, hold on. Break that down for me a little bit. What's a spinal cord neuroprosthesis?
Sure. So think of it like a little device. It's implanted, and it sends out precise electrical signals to the spinal cord.
Okay, so it's stimulating the spinal cord directly.
Exactly.
But how does that translate into movement?
Well, here's the really cool part. These electrical pulses from the neuroprosthesis, they're timed perfectly.
Okay.
They're in sync with the movements of the robot.
Ah, I see.
So as the robot moves the limb, the neuroprosthesis is stimulating the muscles at just the right moment.
So the person's actually participating in the movement, not just being moved.
Precisely.
Wow, so it's much more active and engaging.
And there's another key element here. It's not just any electrical stimulation. They're using what's called biomimetic electrical epidural stimulation.
Ooh, that sounds fancy.
Yeah, well, it's pretty sophisticated. Essentially, they're trying to mimic the natural signals that your brain would send to your spinal cord to make you move.
Interesting.
So, older methods of electrical stimulation, they were kind of like an on-off switch.
Right.
This is much more nuanced. It's like a finely tuned dial, allowing for a much more natural and effective muscle activation.
So they're really trying to work with the body's own systems.
Exactly.
That's really cool. So what kind of robots can they use this with?
Well, that's one of the really promising things.
Okay.
It's not limited to just one type of robot.
Ah, good.
The research shows they've used it with treadmills, exoskeletons, even stationary bikes.
So the kind of equipment you'd find in a rehab center already.
Exactly.
Okay.
And that's really key for making it practical.
Yeah, absolutely.
Yeah. If rehab centers can adopt this technology without having to buy completely new equipment,
Yeah.
that's a big win.
Makes it much more likely to be used widely.
Exactly.
So they've really thought about the practical side of things.
Yeah. And it's very user-friendly, too.
How so?
They've got wireless sensors that track how the person's limbs are moving.
Okay.
And then they automatically adjust the stimulation in real time based on that feedback.
Oh, wow. So it's constantly adapting.
Yeah, that real-time feedback is crucial.
Makes sense.
It makes the therapy more effective and also less cumbersome for the person using it.
So it's intuitive.
Right.
All right, let's get to the results.
Okay, yeah. So they did a study,
Okay.
5 participants, all with spinal cord injuries.
All right.
And what they found was really encouraging.
Oh.
They saw immediate and sustained muscle activation when the participants used this integrated system.
So right away it was making a difference.
Exactly. And it wasn't just a brief burst of activity, it was sustained.
Wow.
It suggests the approach is very effective at its core.
Yeah.
know?
Yeah.
And here's the really exciting part.
All right.
Some participants, even after they turned the stimulation off, they showed improved voluntary movement.
Really?
Yeah.
So even without the system, they were seeing benefits.
It's like the nervous system was starting to relearn, starting to recover.
So this is hinting at the potential for longer-term recovery.
Exactly. It's tapping into the idea of neuroplasticity, the brain and spinal cord's amazing ability to reorganize themselves.
Ah, fascinating.
It's possible that this active engagement, this combination of robotics and stimulation, it's creating the right conditions for lasting improvements.
So it's not just about assisting movement, it's about retraining the body.
Exactly. And, it wasn't just the scientists who were excited about this.
Oh, yeah.
The rehab centers that were involved in the study, they gave really positive feedback.
What did they say?
They said the stimulation technology integrated really smoothly with their existing robotic systems.
Oh, that's fantastic.
Researchers, Nicholas Hankoff and Miroslav Kaban, they highlighted this ease of adoption as a big plus.
Makes sense. The easier it is to use, the more widely it'll be adopted.
Exactly. And that means more people can benefit.
So it's not just a lab experiment, it has real-world potential.
Right.
And they actually took it beyond the clinic too, didn't they?
Yeah, they did.
They showed participants using the system to walk with a rollator and even cycle outdoors.
That's huge, you
It's
know.
amazing.
To see that level of regained independence,
Yeah.
it really highlights the potential of this approach.
To make a real difference in people's lives.
Absolutely.
So I think the big takeaway here is we're moving beyond just passive assistance.
Right.
With this integrated approach, the individual is actively involved in the movement.
Exactly. And by combining the precise guidance of robotics with that targeted spinal cord stimulation, it creates this dynamic environment. You know, it's a potentially more effective path to regaining movement after a spinal cord injury.
So this is really a promising step forward.
It is.
Giving people hope for better, more lasting recovery.
It's important to remember, though, these are still early results.
Right.
Larger clinical trials, more research, that's all needed to really understand the long-term benefits.
Of course. But it's still incredibly exciting.
Definitely.
And it makes you wonder, what's next?
Mm.
What will future advancements in neuroprosthetics and robotics bring?
Yeah, what are the possibilities?
Could we see a future where the lines between assisted and independent movement become even more blurred?
I mean, that's a fascinating thought.
Maybe we'll have these highly personalized rehab strategies that can unlock even greater levels of recovery.
It's an exciting area of research.
Absolutely. Well, that's our deep dive for today. Thanks for joining us.
Thanks for having me.
It's always great to explore these cutting-edge developments together.
Yeah, this is awesome.
Until next